Do you remember that we were stating there is a circular motion where there is, for instance, any given particle which is doing a circular trajectory, and this trajectory of course has a radius from the center towards where the particle is? And do you remember that we were stating that this has a tangential velocity, and due to the fact that this is moving in a circular motion, the velocity is changing its direction, which means there will be generated a radial or centripetal acceleration that goes towards the center. And this radial or centripetal acceleration was the velocity, the tangential velocity to the square over the radius, being, for instance, as well omega squared times r, since the velocity is omega times r, omega being the angular velocity. Well, the question now is, what generates this acceleration? And the answer is pretty straightforward. A force has to generate this acceleration. And if there is a force, mass times acceleration, which is the centripetal acceleration, the force that has to generate this acts as a centripetal force. And of course this is going to be mass times velocity squared over radius, or for instance mass times omega squared radius. And this is the so-called centripetal force. But what is this centripetal force? Well, we have been working with forces previously. A lot of examples, for instance, are gravitational, which is, for instance, the weight, the tension with the string, for instance, the normal, or the friction. Now, is there a new centripetal force? Actually not. All of these can act as a centripetal force. Any given force may act as a centripetal force. Let's take some examples. The gravitational force is the force that is acting between, for instance, the Sun and any given planet. For instance, we can state Earth. Earth is being attracted to the Sun. And of course, this does an elliptical, not circular, but elliptical trajectory. But the reason Earth does not go towards another direction is because Sun is attracting Earth and is acting as a centripetal force. So in this case, gravitational force is acting as a centripetal force. Let's suppose we have a string with a rock, and you are making this rock going with circles with the means of the string. The force that is acting as a centripetal force in this case is the tension of the string. So for instance, if there is no tension at any given point and the string, for instance, breaks, then there will be no centripetal motion. For instance, it could be a projectile motion later on, but no circular motion then lack of tension will mean no centripetal motion. This is the reason why the tension is acting as a centripetal force. A normal force is the one which is acting when there is a surface of contact. And for instance, if we have a loop in a ride, then the cart will start here, will be doing all this motion, and in any given point, for instance, in the top part of the loop, there will be a normal which is perpendicular to the surface of contact, and in this case the normal is acting as a centripetal force, which means no normal force will actually lead to a lack of circular motion. For instance, if there is no track here anymore, then this go towards another point. Being a track there will make this remain in its circular motion. That's an example of a normal being a centripetal force. You remember when you were little and there was a carousel, and for instance there was some guy which was standing up here, such that if you see the motion of this guy or of this particle in this circular motion, this guy will remain in this circular motion due to friction. There is going to be an static friction which makes this guy go into this motion, no friction, then this guy will slip up and then he will actually go outside of the circular motion. That's an example of friction being a centripetal force. In other situations, you might actually have heard of the centrifugal force. Now the question is there a force that is pushing you outside of this circular motion? Remember the example of the rock that we stated previously when we were explaining the tension. And what happened, for instance, we had a string and a rock, right? And there was a point where I explained that if the string breaks, then the rock will go outside of the circular motion, might be do a projectile motion, for instance, but it's not anymore in this circular motion, right? So what makes this go outside of the circular motion? Just a lack of the centripetal force. So is there a centrifugal force? The answer is no. What makes you go out of the centripetal trajectory or of the circular trajectory is a lack of centripetal force. It's not a centrifugal force. And then, of course, this lack of centripetal force, inertia will start to act in this case, and this will make this go towards another direction. Remember that if in this point the velocity is going towards this direction, then the velocity starts to act. So there is the lack of the centripetal force more than a centrifugal force. So remember, any given force can act as centripetal force, and of course, remember, there is no centrifugal force. The centrifugal force does not exist. It's inertia which is acting because there is no centripetal force.